Suppose I try to store some string here like this with double quotation, maybe C, maybe X. Then it will give me an error because this is absolutely not possible. For the other two cases, it was able to do some conversions and it allowed me to do that, but it did not allow me to store a string into an integer type of variable. So it is giving me an error. So data types are very important to determine what are the different, not only what type of value you can store into a variable, but also what type of valid operations that you can perform on those values. Mixing data types is allowed, but you have to keep a lot of things in mind. You may have to do some conversions at times to make your code work as desired. And if you give the correct data type, then you will have fewer bugs and your programs will be much clearer. So let's go over these examples a little bit. So let's go over these examples. Here I have a variable int a, which initially stores the value 10. Then I have another variable double b, which stores the value 3.5. Now I have another variable c of the data type double, and it stores a divided by b. Here a is an integer, b is a double. So integer is divided by a double. So the result that we will get is a double, and it is 2.85 in this case. And we are storing back that result into another double type of variable. So when we print C, we will get this as the result. Okay, now what if we try to store a by b into an integer type variable? In this case, the decimal part will be removed and we will just get 2. This is an invalid operation where I tried to do some mathematical operation using a string. That is not accepted, and that's why it is an invalid operation. And this is the reason why we need data types in C++, because it tells us what operations we can perform on what kind of data. So can you tell me if this is a valid or an invalid operation? Here I have two characters, J and F, and then I have stored those characters into two variables, C and X. And then I am doing a multiplication of those two variables and storing the result into another character, S. Now, if I try to print S, what will I get? As I already mentioned about ASCII values, you know what ASCII values are. This J in lowercase will be converted into its corresponding ASCII value. This F in lowercase will be converted to its corresponding ASCII value, and then this mathematical operation multiplication will take place. And whatever the resultant number will be, that will be further converted back to this character type, because we are storing it back to the smaller bag with 1 byte and the data type char. So here you are storing a number into the character bag. So that number will be treated as an ASCII value and it will be stored as the character that corresponds to that ASCII value. So here we will get this symbol. This is the less than symbol that we are getting here, this arrow. This is another example of mixing types. Let's see what we are doing here. In this example, we have two variables, x and y. They are both integers. And then we have a double type variable called div1. And here in this variable, we are storing x divided by y. Since x is an integer and y is also an integer, keep this thing in mind. Whenever you are dividing an integer by an integer, that result will also be an integer because that division will be considered as an integer division. Even if you store the result back into a double type variable, this division itself will be considered as an integer division and you will get an integer as your result. So here my div1 will be 1, not 1.4. But if I do some typecasting like this, here I'm specifying that I'm not considering them as integers. Rather, I am casting the type double for this operation. And here the result will be a double type. And that result, after the division, the quotient, will be stored into a double type variable which is div2. So here we will get the actual value, which is 1.4. Again, if you do this casting but store the value into an integer variable, then again it will be truncated. So here we have two integers, int a equal to 5, b equals to 2. While doing the division, suppose you do int C equals to A divided by B, and then you do some typecasting here. So if you look at this part, this will be a double result with some decimal part in it, but you were storing it back into an integer type variable C. So if you print C, this will be the output. This will be the output. Okay, 2 will be the output. But if you make this a double, then the output will be 2.5. Assign to a double. Assign to a double C. In that case, it will be 2.5 C. So you need to be very careful when you are mixing types. You have to understand where do you need to specify the type by doing typecasting, or if you want to truncate, then where do you need to use the smaller bag, which is integer? So all these things you have to keep in mind when you are mixing the different data types. So what are the different data types in C++? We will come to that. Before that, just know that data types in C++ are statically typed. That means you must declare the variable's type before even using it. That's a part of the variable declaration. So once you declare the type of a variable, you cannot change the type anywhere in your program. So data types in C++ are strongly typed. That means no mixing is allowed without conversion. If you do not provide the proper typecasting, then it will be treated as the data type that you are currently using. Like we saw before, if you are doing a division and storing the result into an integer type variable, then it will be considered as an integer, even if you have decimal parts in the quotient that you are generating. So these type rules are very strict in C++. And the primitive types or built-in types that you have in C++ are integer, double, char, bool. We will talk more about these primitive data types when we will use them in our examples. And there are some user-defined types as well, called classes, structs, enums. We will not explore all of them in this course, but we will definitely use structs. Then in the next course that you have after this course, you will learn more about object-oriented programming, and there you will create classes. So these are the primitive data types that we will be using in this course. Int for integers, which can store whole numbers, also negative numbers. Double is for decimal numbers. String is for texts, and bool is for true and false values. We will use this a lot when we will work with logical operators. And this is char for storing characters, a single character, be it an alphabet or a special character or a single digit. Those are chars, and we define chars with single quotations like this. And then there is float, which is same as double, but a little different than double. As I told you, doubles use 8 bytes to store a data, and floats use 4 bytes. So the precision in float is lesser than in double. It is up to 6 to 7 places of decimal after the whole number when you are storing a decimal type of number into a float data type variable. But when you are using double, it can store up to 15 to 16 digits after the decimal point when you are storing some decimal number into a double type variable. So that's the only difference that they have. You get more precision in case of double type variables and lesser precisions in case of floats. And also floats use lesser memory. But it depends on you, which one you want to use. In most cases, we just use double because that is more common. There's no other reason behind it. So that's all I wanted to discuss with you today about data types and variables. In the next video, we are going to talk about operators and operands. Those are also two very important concepts that you need to know before you start writing your programs. So I think for now, this thing is very clear to you, how to deal with different types of variables, how to assign value to the variables, and how to be cautious while mixing different data types. So that's all for today. Okay, so bye for now. See you in the next video.
Too many things learned today. My brain needs a break. I'm going to sleep now. Bye.